Good morning, everyone. Welcome to yet another episode of Health Discourse with Sakshi and Sushant. So, hi, Sushant. Good morning.
Good morning.
Today, we will be discussing about chronic kidney disease. We have actually had previous discussions on the relationship between chronic kidney disease, type 2 diabetes, and another angle of cardiovascular disease is something that we have covered in this disease trilogy. But today, exclusive, our focus is going to be about chronic kidney disease. So, Sushant, let us begin this discussion with my first question. So, we have seen that there is a very set mechanism. We do know that due to kidney failures, the chronic kidney disease occurs, right? And there's a very generic idea of how healthcare practitioners are looking at it, right? So, would you like to actually elaborate what is happening inside the kidneys that it is coming to a stage where you need an external intervention to filter out the all the toxins, right? So, I would like you to shed some light on that aspect.
Okay, so we all know, like type 2 diabetes,
Mm.
chronic kidney disease is a global epidemic, and we don't have any preventative solutions as of now, right?
Yes, yes.
More because it is diagnosed very late, and the reason is that the biomarkers or the tests which diagnostic tests, routine diagnosis, which most of the doctors adopt to evaluate the kidney health, right? Such as GFR, right? eGFR, which is glomerular filtration rate, right? Is something which is reduced at a very advanced stage of chronic kidney disease, right? And the changes in the so coming at a molecular and cellular level, the changes in the biology and chemistry when it comes to chronic kidney disease takes place much before the nitrogenous substances such as urea and creatinine, ammonia, and a lot of these start accumulating in the blood, right? So these are obviously late stage, and these have been accumulating, so there's a lot of these metabolism of a lot of these foods, what we eat leads to production of these nitrogenous substances, which are kidney filters out, right? But when we are taking all these things too much every day, daily, it puts a pressure on kidney and your efficiency of kidney goes down, right? And these most of these start there's high circulatory level of these nitrogenous substances, right? And that is what starts the problem, right? So essentially you have to see I'm going to talk about the molecular mechanisms at play which causes chronic kidney disease, and much before we actually uh, try to measure the health of kidneys, right? Much
Yeah,
before. So I
that's
think,
that's totally sensible because what happens is when you come to know about it, it is already too late. You're already
yeah.
put on a dialysis, and there is no early signs that one can actually detect, right? Apart from the blood works and urine
So that's what I
cleaning and
told
all.
you, right? So all these blood work and urine tests, right? All these uh, generally reduced only at a late stage, advanced stage of chronic kidney disease, right? First thing is I'm going to talk about both because a lot of people, even doctors, have never discussed about the role of microbiome in chronic kidney disease, right? We had discussed this earlier, quite long back. We had made a video on this, but let me decode it. So I'm going to talk both about oral and gut microbiome here, right? And that is the reason, also because the current healthcare system sees everything as every organ separately, right? So it's a reductionist biology approach which most of the healthcare practitioner healthcare system follow, right? So all is connected. So your microbiome. So when you're taking, again, people will say we are protein deficient nation and all that, marketing jargons to sell their supplements, right? But what happens is that a lot of these protein is metabolized by your gut microbiome, right? For instance, tyrosine gets converted to precursor, tryptophan gets converted into indoxyl sulfate, then choline and L-carnitine, and lecithin gets converted into TMA, which gets into a liver and gets converted to TMAO, right? We have lipopolysaccharides again, which is again endotoxin. So these are endo and uremic toxins, right? Which are produced and which our kidney filters out, right? So there are millions of units called nephrons in the kidney, right? And our blood vessels in the kidney. So there's a kidney, a whole structure, and so it filters out, and and that's a normal process. But when you're taking too much of it, as I mentioned, it leads to less efficient kidney functions, right? And it leads to accumulation of these bad things, these endotoxin and urine toxins in your circulatory system, right? And again, a lot of people may not know that our kidney tubules is there's a lot of mitochondria in this, because clearance of reabsorption of water and clearance of all these things need a lot of energy, right? And when we are doing this, there's a lot of energy being produced. There's a lot of production of the reactive oxidative species ROS, right, which causes oxidative stress, right? Oxidative stress again. What happens is it triggers, it further damages kidney, one thing, right? It triggers other cascading impact on various other metabolic functions, right? Like type 2 diabetes and cardiovascular disease, as we discussed, but I'm going to talk a bit or at a cellular level, at an enzymatic level today, right? So even we know that people who have risk of type 2 diabetes, we have discussed it that obviously there's an insulin receptor, right, which uh, leads to a intracellular cascade, activates AMP kinase, which tells your ENOs to release GLUT4. GLUT4 is something which goes to the immune, binds to glucose and removes the glucose from circulation. For activation of GLUT4, you need nitric oxide, right? So this is normal process, right? So if there's a lot of, again, oxidative stress, inflammation, there's uncoupling of ENR, so there's oral microbial dysbiosis, probably there's not much nitric oxide, right, produced, and it leads to high blood glucose levels, damage the blood vessels and the nephrons in the kidneys, which again causes chronic kidney disease, right? Even we know type 2 diabetes also through nitric oxide also causes high blood pressure. High blood pressure also damage your blood vessels, kidney. So that is a normal way of why we say, if you have type 2 diabetes or cardiovascular disease, probably you have a high risk of chronic kidney disease. That's a normal way to look at it, right? But another aspect which we have never considered, right? One is, let us start with the oral microbiome. So a lot of these foods what we eat, right? A lot of foods have volatile sulfur compounds. VSC, right? So again, if the oral microbiome is imbalanced, a lot of these microbes in the mouth could convert these foods into things such as ammonia, urease, polyamines, hydrogen sulfide, methylcraftin, right? All these methionine, and all these causes bad breath, and these all are nitrogenous compounds, which also have an impact on your kidney health, right? So again, oral microbiome through causing halitosis could impact your bad breath, or when you have chronic kidney disease, you do have a bad breath because a lot of these nitrogenous compounds are not being, excreted from your urine, or and then again it goes to your breath, right? So these are some of the indications. Some of the early indications are bad breath, right? For chronic kidney disease, right? So again, nitric oxide, which is again produced by certain microbes living in our mouth, right? So if your oral microbiome is imbalanced, it doesn't produce nitric oxide. There is in uh, hyperglycemia, hyperglycemia, and there is chronic kidney disease, right? Second aspect is at a cellular level, what happens is when there's a lot of oxidative stress because of a lot of these nitrogenous compounds being produced, and mitochondria getting into act to generate a lot of energy to clear all these things, right? There's a lot of oxidative stress. Now, oxidative stress do impact kidneys. It also oxidizes a lot of metals which are there on the protein and the enzymes, right? So we know every cells have enzymes have protein which perform biochemical reactions, biochemical functions, right? So these metals could be zinc, copper, magnesium, manganese, right? These are normal metals are required for the cellular processes. So oxide these metals. So these cells cannot function. These enzymes and protein doesn't function. Cell become dysfunctional, and then the cell cannot produce nitric oxide, and then you have you know risk of type 2 diabetes and even cardiovascular disease, right? So it's not only that that type 2 diabetes is the risk of chronic kidney disease. Even chronic kidney disease could cause type 2 diabetes, which will never be covered in your CGMs, which will never be decoded by your CGMs and the VA, right? Because
Basically, there's a reverse mechanism which is also working here. It is
yeah,
not only about that you go from type 2 diabetes to kidney failure. Could be either ways. Even
yeah.
those with having first kidney issues, then that could also lead to type 2 diabetes. Well, I do have certain experiences in my family of these things. So yes, I could relate to that, right?
Mhm.
So, Sushant, my next question is, since you mentioned that nitric oxide has a major role to play in this whole
Mhm.
mechanism, right?
Mhm.
Now, what should people do in order to improve their nitric oxide production? What should be their course of action in this?
See, it is very complex thing because nitric oxide is produced by two pathways, right? One is endothelial cell, which is lining every single blood vessel, right? The ability of these cells falls as we age. So by the age of 50, the ability of these cells to produce nitric oxide reduces by 50%. Again, you know, there are a lot of multiple factors which could disrupt nitric oxide production. One of them is obviously, uh, consuming a lot of these processed food which have vegetable oil, processed seed oils, corn seed oils, and all that, which changes your cell structure and fluidity, right? Which makes your cell dysfunctional, right? That is one of the reasons. Sugar is very sticky. It sticks to your enzymes, to your proteins. It makes your protein dysfunctional, right? The metals on the protein, so advanced glycation projects products produced as a consumption of overconsumption of sugar could cause, right? Again, fructose, consuming a lot of high so-called packaged fruit juices, right? These could impact. So these are certain food examples, but it's inflammation and oxidative stress which causes, right? Again, inflammation, a majority is caused by your overall gut microbiome, right? For instance, histamine, oxalate, a lot of these metabolites, harmful metabolites being produced by your gut microbiome could trigger inflammation, right? Like in case I mentioned, right? So this uncouples the nitric oxide synthase, endothelial ENOS, with the which is supposed to be coupled with the cell is uncoupled, and then there's a disruption in nitric oxide production, right? So there are multiple factors, which causes inflammation, which causes oxidative stress. So again, oral microbiome, we know nitrate, nitrite conversion, right? You need to have right set of stomach acid to actually convert nitrite into nitric oxide, right? If you are on PPIs, it disrupts your nitric oxide production, right? It even increases your risk of cardiovascular disease and chronic kidney disease, right? So that this is really really important, and people who have chronic kidney disease also have you know uh, neurological issues also because the neuron, nitric oxide change NNOS, right? Neural NOS is something which regulates your cerebral blood flow, right? It also impact your neurological issues, right? So that's why I'm not sure, people who have chronic kidney disease also have some sort of cognitive
Dementia is one
dementia.
of these
I'm not
symptoms.
sure. I can't say, but cognitive dysfunction is there.
Yes, cognitive
Forgetful.
dysfunction is there, but dementia is actually one of the scenes, one of the experienced symptoms, right,
Mhm,
among
mhm,
multiple people. And
mhm.
also, at some point, Alzheimer's is something which develops.
Yeah, and if you see, the cost of there is a very huge economic cost of chronic kidney disease in terms of cost of every individual spending more than 25,000 rupees a month on
Yes.
dialysis, drugs, tests, physicians,
Yes, yes.
hospitals,
That
right?
that
Treatments.
that is totally sensible. One has to spend that much, on keeping himself just
No, I want to
working
ask,
normal.
I want to ask you, Sakshi. Since you have said that someone in our family actually lost their life to chronic kidney disease, right? And
Actually, two people that I
right,
know.
right.
Yes.
So was all the costs covered by the insurance company?
Mostly, yes, but the cost of physician visits and a couple of what happens is that there's a certain coverage. They give you,
Mm-hmm.
even if it is a government insurance, they give you a certain amount of coverage. Okay, this is the coverage based on
Mm-hmm.
the like based on the severity of that particular condition, right?
Mm-hmm.
So there are two examples here. So if you have a mild dialysis thing going on, which is like twice in a month, so they will give you a certain amount of coverage, right? But
Mm-hmm.
post that, then you have to pay yourself. Sometimes that also happens that it is not really cashless. They will reimburse it to you. Yeah.
Okay. Okay.
So it actually depends on the coverage,
So
the
I'm
kind of
asking
coverage.
because since it is diagnosed with late stage, there's hell of cost involved, right? So some point in time, probably you may have to shell out from your own pocket. Insurance company may not
Yes.
cover it, right? So
Sometimes you have to shell it out from your pockets because
yeah.
what happens is sometimes what happens that there is a certain amount of period that they assume ki dialysis will go on for this much months. They give you a specific permission for cashless
Mm-hmm.
treatments from a hospital,
Mm-hmm.
right? And if that expires, then you have to either pay from your own pocket, or you have to extend that by supporting all the tests and all that you have to go through from your pocket only,
Okay.
right? So
Okay.
this is a very vicious procedure, Sushant. It just goes on, and there's no end to it. You cannot say that the patient is getting cured or he's getting better. He's only getting worse because after the dialysis, as you can see, a person tends to lose his weight. He becomes, there's no fat left inside of him. There's no skin left. It's all bones, which is actually visible. I've seen that.
Yeah.
Yeah. And
Yeah.
then
So
there's a
so
tube. And then there's a tube somewhere on the this hand, on the arms, or maybe on the neck for that dialysis thing to go on. And it is very painful. It's a very painful life, I should tell you.
yeah, because this is again, dialysis is something where you will not be able to survive most probably, right? Even if you're able to survive, there's a huge cost and emotional cost and economic cost involved, and also,
They only
there.
have one solution. They will ask you to undergo this, what do you call it, kidney replacement surgery, right? That kidney donor thing,
But again,
right?
the root cause is not addressed, right? So,
Yes.
so
It
for
and there
everyone,
is there is no chance whether you will survive it or not, because sometimes what happens, even if the kidney is compatible with your blood group, it might or may or might not suit you. It is entirely a case of luck in that case. Doctors will say there's a 50% probability the person will survive, or even if with the other kidney, if you have a kidney replaced, right?
Mhm.
So then also you may have to go through a dialysis in order to make it work and suit your body. That is a very vicious cycle, I'm telling
Yeah,
you.
and again for everyone, most probably people go for these blood test and urine test, right? Which is again at a late stage, because if you go early, it will never come up. It will never show that it's a reduced GFR or albumin level, right? So again, few of the indications which I could point out, and again, these are just general indications, but obviously, you need to for specifics, you need to understand the functions of the gut and oral microbiome, right? Again, nitric oxide, the deficiency of loss of functional loss of nitric oxide is the first symptom is erectile dysfunction, or the impact on the sexual function, right? Both for male and female, right? Bad breath, right? Again, halitosis is one of the early signs of chronic kidney disease, right? Then obviously, the lot of these, if you are taking too much of protein, or probably, a lot of other inflammatory causes. So it may not be, only protein, but that is one of the reasons, if you have oxalate issue or histamine intolerance. Again, it could cause it could uncouple the nitrogen synthase. You may have a type 2 diabetes issue, and then you may have chronic kidney disease, or you're taking a lot of protein, the peak resolve and oxalosulfate, TMA, which all could further put oxidative stress because your kidney becoming inefficient, less efficient, right? So from that perspective, the early signs, obviously, we actually measure the molecular insights, right? So we could tell you
Yes.
what is your peak resolve production, what is your endocyte substrate production, what is your TMA production, what is your LPS production, what is your
That too, through
ammonia
oral
production.
also is something we can detect. I mean, oral is
Yeah,
the first way that we can actually detect the onset of chronic kidney disease and whether you are having a risk of it or not. Yes.
yeah, we also give you the risk. So we look at various pathways. We look at urease pathway. We look at ammonia production. We look at methionine. We look at S2S. We look at polyamines. We look at nitric oxide. These are the pathways we consider when we talk of chronic kidney disease or halitosis. Right, halitosis is early signs. So essentially, do not think that having first thing is only risk of type 2 diabetes causing chronic kidney disease. It could be other way around, right? And if
Mm-hmm.
you have a risk of chronic kidney disease, you also have a high risk of type 2 diabetes, which will never show up in your CGM because the nitric oxide uh, measurement of nitric oxide production is not done by any of the variables, right? Again,
Right.
it is very relative, right? And because nitric oxide is something which regulates your blood flow, oxygen uptake and delivery. So it is one of the essential gas molecules which is required, right? Even
Right.
even the oxygen delivery to every portion of the body is controlled by nitric oxide, right? So this is really really important, right? And that's why the detection of chronic kidney disease at early stages is vital, which is not being done by any of the tests right now, right? So my urge to everyone, to all the people, uh, they could fix. We are the only one. We focus on the microbial genes expression and the functions, not on the existence of microbes. So a lot of companies would tell you that okay, you have this microbe, you have that microbe, doesn't matter. So me and you, two people would have different set of microbes. They be producing same metabolite which is causing chronic kidney disease, right? So again, uh, it is something. So we could help you understand your biology. We could help you with the downstream functions of your gut and oral microbiome, right? Even for nephrologists, probably who are solving the chronic kidney disease and probably could not, have the early signs, we can help them understand the early
Yes.
signs of the disease. We are happy to collaborate with nephrologists probably on gut and or oral microbiome solutions. Yeah.
So, yes, Sushant, that's totally correct. So, with this, we have come to the end of this discussion. Any further points you would like to add here before concluding this?
Yeah, so do not fall for bad diets. Understand your biology. Do not wait for even especially for chronic kidney disease. These blood tests or urine tests are not going to tell you until unless you have entered the advanced stage, right?
Yes.
So understand any disease develops 2 decades before the symptoms show up, right? And management of disease is not a solution. Probably you should more look at your biology, you look at the function of the microbiome. Now there's a lot of evidence and research now that your microbes even in your gut and mouth have a vital role to play in disease such as chronic kidney disease, type 2 diabetes, cardiovascular disease, right? So that's just what I wanted to say, right?
Thank
And
you, Sushant. This was a very interesting discussion. It gave us a lot of insights on chronic kidney disease. So, thank you, Sushant. Have a good day.
thank you. Have a good day. Bye bye.